All right, guys. What we're gonna do today, we're gonna introduce a topic called Markov chains. We're gonna look at a simple example of this. Okay, I think it's really fun, and it's a really powerful way of modeling the world. So suppose that you have states, right? And so you have states. So for example, it could be in the example that we're gonna give, we're gonna model the states to be sunny and rainy. And we're gonna so we have states and then we have transitions between states. So transitions are typically probabilities, transition probabilities. Now consider the following, right? So suppose that today is sunny, and then there's another state called rainy. Well, what is the if today is sunny? What is the probability that tomorrow? Sorry, if today is sunny, what is the probability that tomorrow will be sunny? Well, let's say the probability that tomorrow will be sunny is going to be 80%. In which case, we would say that it's 0.8. But that means that if there are only two states, it's either sunny or rainy, then that means that if tomorrow has 80% chance it's sunny, then that means that there is a 20% chance that it's going to be rainy. So it's going to be 0.2. Now, similarly, suppose that today is rainy. What is the probability that tomorrow will be rainy? And let's suppose that if today is rainy, then the probability that tomorrow will be rainy is 60%. If that's the case, we say that 60% is 0.6. But if that's the case, then the probability that tomorrow would be sunny would be 40%, which is 0.4. Okay, so what's the value of this? The value of this is that, okay, so if so the way that this works would be that once you have this is known as a Markov chain. Now oftentimes when mathematicians think about this, right, they try to encapsulate or encode this diagram, this Markov chain, into something more concrete, like a matrix. So the matrix that they would have would be that, okay, if this is sunny, right, if this is sunny and if this is rainy, if this is sunny and this is rainy, right, okay, so if this is sunny and tomorrow will also be sunny, it's going to be 0.8. If today is sunny and tomorrow is going to be rainy, it's going to be 0.2, right? If today is rainy, right, today is rainy, tomorrow is going to be sunny, it's going to be 0.4. And if today is rainy, tomorrow is going to be rainy, it's going to be 0.6. So this would be the matrix. Okay. So the way Markov chain is good is that, okay, so this is the metric that encapsulate this Markov chain relationship. Now, there's going to be an initial state, and then there's a future state. So there's an initial state, and then there's a future state, final state, or tomorrow, like the next state basically. So if today, let's suppose the initial state for today is going to be today is sunny, then we are going to say 1, 0. This would be sunny. What about rainy? Rainy would be 0, 1. Okay. So to get the final state, or the next state, maybe the state for tomorrow, right? We could just do something like this. We could say, if today is sunny, it's going to be 1, 0. That means that the 1 here means that the probability of today being sunny is 100%, and the probability of today being rainy is 0%. Then it's going to be 1, 0, 0.8, 0.2, 0.4, 0.6, and then we do this computation. It's going to be 0.8. This row and this column is going to be 0.2. And this would be the probability for tomorrow. That this would be the final state, or the state for tomorrow. So tomorrow, we have a probability of, or 80% probability that tomorrow will be sunny, and 20% is going to be rainy. Now, this is the state for tomorrow. What about the state for tomorrow's tomorrow? So we could plug this as our initial state, and then use the matrix to compute the tomorrow's tomorrow, right? The next day, the second day. 0.8, 0.2, 8, 2, 4, 6. And we're going to have 0.72 and 0.28. What this shows is that this is the second day. What this shows is that there is a 72% chance the second day is going to be sunny, and there's a 28% chance that the second day is going to be rainy. Pretty cool, huh? All of this just emanate from this simple little diagram. So this is a basic introduction to Markov chain.